Hello everyone, welcome to the Maths Guild. Today we're going to be talking about drag forces. Okay, so just a free fall, but instead of thinking a free fall constant velocity, we're thinking what happens as it, has a bit of air resistance, has a bit of drag. So here I got this presentation here. This is what you think would happen if you ignore air resistance. But if you don't ignore air resistance, if we do the opposite and actually include some air resistance, what we get is this little drag force, Fd. And Fd, we need to remember, is proportional to negative velocity squared. Okay, I should probably say the magnitude of Fd. What this means here is that it means as the velocity increases, so does the force, which makes sense, right? If you get something and it moves faster, it's going to experience more drag. Okay, you're going to run faster, you're going to experience more drag. You're going to feel the air pushing on you more. Okay, and v squared, this is things that we have just gotten from measuring, right? You can do some measurements and you can find this relationship just from real world measurements. Okay, let's have a look here. So, we're going to have a resultant acceleration, which means we're going to have a resultant force. Okay, so our resultant force here, so be our resultant force, ma, F equals ma, referring to a resultant force, that's equal to mg minus Fd. Now remember, minus Fd, I should probably say magnitude of Fd, okay, we're thinking of the magnitude. If we go back to this equation, we're thinking that the magnitude of Fd, and if you're wondering, the reason we take the magnitude of Fd is because this has a direction, okay? We're just kind of ignoring the direction, we're just thinking, what about the force, okay? And we're going to say that's equal to negative mu v squared. Well, mu is just some constant. Okay, mu is a constant, mu is greater than 0. And we can just replace that, put that into the equation, and we're left with mg minus mu v squared. Lovely. Now, remember, we have v, we have a, we don't want that, we want one thing. So what we can just go ahead and say is that a is actually just a derivative of v. Okay, that's what it is. Okay, acceleration is the derivative of velocity. So we're left with m, and then with dv over dt equals mg minus mu v squared. Now, this thing, you can't use an integrating factor method to solve the equation. It's impossible to do that because you have a v squared. It's not linear. Okay, which kind of sucks. But it's fine, it's still solvable. All we have to do is just think a little bit, right? Let's get dv over dt separated and think, well, we only have one other variable. There's no t, it's just v. So really what we do is if we can get this in terms of v with respect to v, we could integrate it. Right, and we can. We can flip over this fraction, because this is really just a fraction. And we have to flip over the other side to get m over mg minus mu v squared. And there we go. We're left with this. And you can see we can integrate with respect to dv. We can get t equals, and then dv. That's what we want. Now, the problem is, if we want to integrate this, we do need to get this into partial fractions. It's going to be a bit difficult otherwise. Because we have the v squared. But that's possible, that's fine. This is actually just a difference of two squares, if you've noticed. We're going to have a square root of mg minus mu v, and then square root of mg plus mu v. Now, if you're wondering why mu and not square root of mu, one, it just looks nicer, and two, mu is just some arbitrary constant. Okay, all mu is it's greater than 0, which means that we're fine in saying just mu. Okay, mu is just some random constant, I don't care what mu is. Okay, we're just going to, if we square it, if we divide it by something, if we times it by something, we don't care, we're just going to keep it at mu. Okay? Lovely. Let's go ahead and separate this out into partial fractions. So we're going to have a over root mg minus mu v plus b over root mg plus mu v. Okay, so this is quite a useful method. I don't like integration by partial fractions. It's a bit long. But yeah, okay, and then I'll just use crisscross smile over here to get that into this sort of form. And you probably know how this goes. you probably know how this goes. This thing is equal to m, okay? Because the denominators are the same, but this top part here is different. So we're just going to go say m is identical or equals, but identical is probably the best way to put it. Okay, is technically the correct way to say it, and mathematicians love to be correct. Minus mu v. Cool. And then what we can do here is we can just we could compare coefficients. I'm not going to do that. I'm literally just going to say, well, let's say v is equal to well, we want this thing to be 0 and the other thing not to be 0. So if we say v is equal to negative, actually no, you know what, I think it would better just compare coefficients. Yeah, let's compare coefficients. So just expand it out like so. Compare coefficients, honestly, it's usually the best way to go because you compare coefficients more. Okay, it's a smarter way to do it. It's a bit nicer in my opinion. But you can set v equal to like a certain value to get it to cancel out. I personally didn't do that. I mean, it works fine. It works fine. I just like doing it this way. Okay, so let's get v. Now v is a variable, so we separate out v to get a mu minus b mu plus, and then like the rest, which is just constants. So I guess mg a plus b. Okay, so we know that m is going to be equal to the constant terms. So we can say that root mg a plus b equals m. And then we know that this part here must equal 0. So a mu minus b mu must equal 0. Don't have anything for mu. So that means we get a equals b, which is nice. If a equals b, we can go back to here and just replace that with 2a root mg equals m. And then solve for a, which is going to be m over 2 root mg. You can times by root m over root m. Essentially, we're just rationalizing. You could do that. I'm not going to do that, to be honest. I think it's better just to keep it this way for now. But yeah, and we know this is also equal to b from this equation. Lovely. So we found our two constants. Right. Each of them are going to be m over 2 root mg. So we know that dt over dv now is equal to, what was it again? There it is, m over 2 root mg. Okay, m over 2 root mg. There we go. And then we're going to write this as 1 over root mg minus mu v plus m over 2 root mg 1 over root mg plus mu v. Okay, so let's see what we can do here. We could expand these brackets. I think that might be a nice thing to do, just to simplify it out a little bit. So we'll be having m and then 2 mg. Now this is a bit complicated. You get root mg times mu. I don't really know, so you know I'm going to do the same thing we did before and just absorb it into this. Okay, mu is different. Mu has changed. Okay, mu is just some arbitrary constant. So we're just going to change it where we feel fit. So we got this here. Let's just take t, integrate both sides with respect to v. So we're going to do this separately, like so. And we're going to get these two fractions. Okay, we're expecting, and now it's just a bit of integration. You should know how to do this. It's going to be m and ln, and then mg minus this little thing. So essentially, this should be the same. Right? But we're dividing by this. We don't want this to be there, because if we take the derivative, we're going to get this negative mu, so we got to divide by that to get negative m over mu. And the same thing here. This is actually going to be very similar. Just for plus in here, which means that we do have to divide by positive mu. There we go, we've solved it, and obviously yes, never forget plus c. So let's have a little go at what plus c could be. And what I'm just going to say is that, well, at t equals 0, I want v to equal 0 as well. Okay, that's what we want. We could actually say, you know what, let's just set it equal to v naught. Okay, good thing maybe v naught. Might be a good idea. So v equals v naught. Honestly, I'm just going to say equal to 0. Yeah, we say equal to 0, just to make it a bit easier. So t equals 0, so put in these values. 0 equals negative m over mu. Ln, and then that's 0, so it's just going to be 2mg plus m over mu ln of 2mg. Oh, well, these cancel. Okay, plus c, so you just get c equals 0. Lovely. Let's go ahead and just solve. So mg, take out the mg, oh, it's not mg, m over mu, sorry, God, m over mu. And this is just a bit of simplifying. So here we're going to have ln. Now, we can use our log laws here to get this into one big fraction. And we'll be left with this. Then we can divide both sides by m over mu, so we get mu over m to the t, and then we can just raise both to the e. Right, we're going to raise to the e to get rid of that ln, so we're just left with 2mg plus mu v over 2mg minus mu v. And then we just solve for v, which isn't too difficult. Okay, we times both sides by the denominator to get 2mg minus mu v e to the mu over mt, just timesing both sides. And we're trying to get a v, isn't it? So that should be mu. We just add that to one side, get that, and take out the factor v. So we take out the factor v, and then we get mu plus mu e to the mu over mt. And then just take the other bit of it, so 2mg e to the mu over mt minus 2mg. Lovely. And then we can just divide both sides with that. So that v equals 2mg e to the mu over mt minus 2mg over mu plus mu e to the mu over mt. And there we go. That's your formula. Bit complicated, but there you go. You've solved for v with these conditions over here. These conditions are important. And yeah, that's the equation. So I thought I'll give you guys a little bonus. I have this little demonstration on Desmos, and this will just show off what happens. So here, if I change, this is the maximum velocity. So basically, this is the velocity that it will reach, right? The terminal velocity you can think about. Okay, what's the terminal velocity? And this is just by thinking about limits, because this does have a limiting value, right? As, for example, t gets really, really large, this will approach some value. And that value here in this case is v max, as you can see. Then you have v naught, which is really just a starting velocity. So whatever, I did include the starting velocity, and I didn't do that in my formula. And yeah, you can see this is how it looks like, which makes sense, right? That's how you think it would look like. But yeah, so thanks for watching.